complete guide to full-stack Solana development with React, Anchor, Rust, and Phantom. Code examples to go with a blog post available. In a complete guide to full-stack Ethereum development, I did a deep dive into how to build a full-stack DApp on Ethereum, which can also be applied to other EVM-compatible chains like Polygon, Avalanche, and Ethereum layers like Arbitrum. In this guide, I want to dive into Solana to show you how to build a full-stack DApp. I also want to introduce the ecosystem and the developer tooling to you to hopefully help you get up and running building your own ideas and applications going forward. Solana developer overview. As someone who just started learning Solidity and its ecosystem about 3 months ago, I kind of assumed it couldn't be that much harder to get up and running with. I was wrong. Parts of the developer tooling are really nice and polished. The Solana CLI and Anchor, while the rest of the ecosystem, and even the documentation for Anchor, which to be fair, is very new, leaves a decent amount to be desired. That being said, once you get the hang of everything, it quickly becomes much easier to understand how to start implementing your own ideas and begin experimenting. One of the keys to finding answers is to be vigilant about hierarchy across all of Google, GitHub, and especially the various Discord servers for Anchor and Solana. The developers in those channels have been extremely helpful, especially Armani Ferrand, who created the Anchor framework. Get familiar with the search feature. You can often find answers to your questions in past discussions in Discord. Project overview. The tooling we'll be using today includes This includes a really polished and well-documented key for interacting with the Solana network. This is going to be a local Solana node that we can deploy to for testing. Let's start loading. In this project, you'll see 4 main folders. Where our front-end code will go. This is where the Rust code lives for the Solana program, where the JavaScript tests for the program live. A basic deploy script. Let's take a look at the program that was created for us. Anchor uses and enables us to write, read, embed DSL That abstracts away many of the more complex low-level operations you'd typically need to do if you were using Solana and Rust without it, making it more approachable for me. This is probably the most basic program you can write. The only thing happening here is we are defining a function called initialize, which when invoked just exits the program successfully. There is no data manipulation at all. To compile this program, we can run the anchor build command. Once a build is completed, you should see a new folder named Target. One of the artifacts created is an ID L located at IDLs are very similar to an ID initiality, or a query definition in GraphQL, and we will be using them in a similar way in our JavaScript tests and frontends to communicate with our Solana program via RPC. We can also test out our program. If you open tests .js, you will see that there is a test written in JavaScript that allows us to test out the program. The test should look like this. There are a couple of things to learn from this test that are important and we'll be using in the future, both in our tests as well as in the front-end JavaScript client. The provider is an abstraction of a connection to the Solana network, typically consisting of a connection, wallet, and a pre-flight commitment. In a test, the Anchor framework will create the provider for us based on the environment, Anchor. Provider, ENV, but on the client we will need to construct the provider ourselves using the user's Solana wallet. The program is an abstraction that combines the provider, IDL, and the program ID, which is generated when a program is built, and allows us to call RPC methods against our program. Again, like with the provider, Anchor offers a convenient way to access the program, but when building out the front end we'll need to construct this provider ourselves. Once we have these two things, we can start calling functions in our program. For example, in our program we have an initialize function. In our test, you'll see we can invoke that function directly using very common pattern that you'll use a lot when working with Anchor, and once you get the hang of understanding how it works, makes it really easy to connect to and interact with a Solana program. We can now test the program by running the test script. Building Hello World. Now that we have our project set up, let's create something a little more interesting. I know that, as a full-stack developer, most of the time I'm wondering how to do CRUD types of operations, so that's what we'll look at next. The first program we'll create will allow us to create a counter that increments every time we call it from a client application. The first thing we need to do is open programs, Miss Solana, src, lib, rs, and update it with the following code. In this program we have two functions, create and increment. These two functions are the RPC request handlers that we will be able to call from a client application to interact with our program. The first parameter of an RPC handler is the context struct, which describes the context that will be passed in when the function is called and how to handle it. In the case of create, we are expecting three parameters. base accounts, user, and system program. If traditional Chinese characters transcribed will P9 account attributes within constraints and instructions that are related to the proceeding account were declared. If any of these constraints do not hold, then the instruction will never execute. Any client calling this program with the properties account can call these RPC methods. The way that Solana deals with data is much different than anything I've ever worked with. There is no persistent state within a program. Everything is attached to what are known as accounts. An account essentially holds all of the state of a program. Because of this, all data is passed by reference from the outside. There are also no read operations. This is because all you need to do to read the contents of a program is to request the account. From there you are able to view of the program state. To read more about how accounts work, check out this post.
Right.